So I'm Paul Cotius with IBM's T.J. Watson Research Center. I'm the chief engineer on this project, and this morning IBM announced its third generation supercomputer, the Blue Gene Q. And we're very proud of this machine. It's scalable to 100 petaflops, so it's focused on trying to bring intense computing, easy to use, intense computing to the customer to solve a wide variety of problems. So there's three things we're after. We're trying to create a computer that's easy to use. We're trying to create a computer that's very reliable, that will be there to finish the task. And we're trying to create a computer that's more and more importantly energy efficient. So this machine is actually the most energy efficient computer on the planet, supercomputer on the planet. It's been awarded the top of the Green 500 list. And it's about a factor of 2 more efficient than the next machine on the planet. So it's a very efficient computer. I'll take you through some of the things that we did to make it that efficient. It's an extremely reliable computer. Blue Gene L and Blue Gene P, the previous generations of Blue Gene, were known for their incredible reliability. And this machine is engineered even more so to be very, very long-lived. Let me show you what's inside. These node boards are the workhorse. Each one of those contains 32 processing chips. They're all water-cooled, connected by a 5-dimensional toroidal network. The network of Blue Gene is some of the secret sauce in it. It's a very, very low power, very efficient, adaptive network built into the processing chip. The power supplies are the only air-cooled part of this. Everything else is water-cooled, 94% of the power by warm water, so it doesn't take chilled water, very, very efficient to operate. That's part of the secret of how we become such an efficient machine. These are industry standard PCI Express cards, connect to InfiniBand or Ethernet, even solid-state storage cards can go in there. These are the same processing nodes that are water-cooled, but here they're air-cooled, obviously, because this is an air-cooled drawer. And here we run the Linux operating system and control these cards. So this is where all the data flow happens. They're optically connected so that we can make the connections to the compute nodes and flow the data from the compute nodes to the I/O nodes back and forth.
As the performance of technical computing solutions continues to increase, one of the problems that users run into is the storage and management of ever-increasing amounts of data. And we have a solution for that in the building block solution based upon GPFS and our DCS 3700 storage subsystem. And GPFS itself is a software product. It means General Parallel File System. And it allows you to take some number of redundant servers and associate them with the logical units defined on the DCS 3700 subsystem and export those either via our proprietary GPFS protocol or via standard NFS protocol. It can also be scaled vertically to increase the storage that is allowed in it, and can be associated with hierarchical file systems such as HPSS and our TSM product.
So this is the DCS 3700 storage system that Dan mentioned. It serves as a great foundation for GPFS. It's very dense, and so you can fit 60 drives into this 4U enclosure. And it's got 5 individual trays that slide out. You can do hot swappable with the drives, supporting up to 3 terabyte drives. And so as Dan mentioned, you basically have a building block approach where you just start replicating this to achieve the performance and capacity that you need.
Hi, I'm Dan Tuckler. I'm VP of Product Management for IBM System Networking. More and more we're seeing networking as the unifying fabric, tying together servers, storage, and other components within the data center to create a solution. And that's what IBM's all about, is creating solutions, not so much point products, but combining the solutions to really tackle customer challenges and really provide strong solutions for them. So in networking, we're seeing a couple of trends right now. One of the trends that we're seeing is this broadening out of networks. So instead of having one core large switch and condensing all the traffic on one core choke point, we're seeing a broadening out of the network using multiple switches to create a lot more bandwidth. One of the new switches we just announced is the 8316. It has 40 gigabit Ethernet, so really taking the connectivity up to the next level, providing high bandwidth to connect these top-of-rack switches. Typically what we see is top-of-rack switches connecting all the servers in the rack and providing a lot of bandwidth, but they need a place to aggregate, and so that's where the 8316 is used. One of the other things that's a challenge in building out these data center infrastructures is support of virtualization. So we've also announced our 4th generation VM-ready product line, which recognizes virtual machine traffic and gives network administrators tools to deal with the traffic across the network. VM-ready has now been evolved to include standard technology called 802.1 QBG. And what this technology does is supports virtual machine movement in a very industry standard way that allows interconnection of components from different vendors. This is what our customers are always looking for, is open solutions, but using the best of breed products that they can get from IBM. We've seen the results of the top 500, and Ethernet continues to be a very strong supplier connectivity for HPC environments, continuing to grow. Ethernet is a strong part of the story here at IBM. IBM has made a statement by acquiring Blade Networks that it's the whole solution that counts. It's Ethernet tying components together and creating solutions. And that's what we're here for. It's really exciting to be part of IBM, and thank you.